So this is our course project presentation of automotive systems, which is about anti-lock braking system. Uh, so this is introduction of our project. So anti-lock braking system is anti-skid braking system, which is used in aircraft and land vehicles. Contains an automated system that prevents wheels from locking, which continuously maintains traction with the road surface, consequently providing more control to the driver over the vehicle. Next is the comparison between traditional and anti-lock braking system. In traditional braking, the pressing on the brake pedal stops the vehicle using calipers to slow down the wheel rotor. But in emergency situations, slamming hard on the brakes, traditional brakes causes locking of the wheels, which makes driver to lose control over vehicle. But in ABS, during emergency situation, hard slamming on the brake pedal results in activation of automated system. This helps driver to easily maneuver vehicle even during the slowing down, which is the case in the diagram as shown. So now we will discuss the applications. First is the easy turning. Easy turning in emergency situation with the use of ABS comes from the concept of rolling of the vehicle. The contact point of the wheel will always remain at the zero velocity due to translation and rotational velocity in opposite directions. During turning, the front rolling wheel satisfies this condition by rotating the whole vehicle about an instantaneous center. In traditional braking, brakes wheels lock due to hard braking in emergency, which eliminates the rolling velocity from the contact point of the wheel, and vehicle skids due to remaining translational velocity of the contact point. Next is the short arc braking distance. So one of the main application of the ABS is reduction of the braking distance. The distance coefficient of the wheel tire doesn't change like other materials with respect to the slip ratio as shown in the diagram. Coefficient of friction reaches its maximum value around 12% of the slip ratio. Therefore, an automated system is designed such that it frequently releases the brake to the maintain maximum value of friction coefficient, which shortens the braking distance. So next is the prevention in rotation of vehicle. So during skidding, all four tires experience different sliding friction due to different road conditions. This generates torque, which causes disbalance and rotates the entire vehicle. To prevent this, an ABS automatic system releases the tire with high sliding friction, consequently balancing force on all wheels. This reduces the torque over the vehicle and reduces the chances of disbalance.
Next is working principle. In working principle of ABS, it prevents the wheel from locking up, thus avoiding uncontrolled skidding. So it means the working principle. In working principle of ABS, it prevents the wheel from locking up, thus avoiding uncontrolled skidding. It means when we apply or slam the brake hard, uh, our wheel stucks and it stops rotating. So it starts to skid, and we want to avoid that. So main thing in ABS is that only. So it does avoid by using the modifying the brake fluid pressure, which is independent of amount of pressure being applied on the brakes, which we generally apply while slamming on the brake in emergency situations. So what it does, it does speed of the wheel back to the minimum slip level that is mandatory for optimal braking performance, which is 12% of the slip ratio. It is achieved with the help of speed sensors, hydraulic control unit, and electric control unit. In hydraulic control unit, there are several components. Main is accumulator. It is used to store hydraulic fluid to maintain high pressure in the brake system. Next is anti-lock hydraulic control valve assembly. This assembly controls the release and application of the brake system pressure to wheel brake assemblies. Next is booster pump. The booster pump is used to provide precise hydraulic fluid to ABS. After that, a booster and master cylinder assembly, it needs to modulate hydraulic pressure in the wheel circuit during the ABS operations. Fluid accumulator temporarily stored brake fluid that is removed from the wheel brake unit during ABS cycle. And last one is hydraulic control unit. The unit may have one pump and one motor, or it have one motor and two pumps. And then we have a main valve. This is a two position valve in and is open only in the ABS mode. Modular unit. The modulator unit controls the flow of pressurized brake fluid to the individual wheel circuits. Solenoid valves. The solenoid valves are located in the modulator unit and are electrically operated by signals from the control module. After that, we have electrical components. In this, the ABS wheel speed sensor is shown and ECU is shown in the diagram. ABS control module, it monitors and system operation and controls anti-lock function when needed. Brake pedal sensor, it is generally used so that the vehicle behind our vehicle, they can know that our car is slowing down and might we can stop. So it is just for the information for the car which is behind us. Next is wheel speed sensor. These are used to sense the vehicle speed, and based on the how much speed our vehicle is, we can have the frequency of stopping and applying the brake again. uh, that is varied on the speed of the vehicle or speed of the rim. Now there are three types of ABS. First is four channel four sensor, three channel three sensor, and one channel one sensor. So in four channel four sensor, we have four wheels, and for example, we can see in this diagram we have four channel ABS. In this we have speed sensor on all of the tires, and uh, all of the wheels also have a valve. Hence, each wheel is monitored individually to achieve maximum braking performance. So, for example, let's say as we discussed in applications, let's say on four of the all of the wheels, there is different surface under the wheel. Let's say there might be grease on the road, or there might be ice. So coefficient of friction will be less there, and we might apply different braking force on that tire versus the another tire which is having more traction under it. Next is three channel three sensor. It in this wheels have speed sensor and a valve each, while rear wheels have only one valve and speed sensor. So rear wheels have to start to lock up before the ABS will activate on the rear. So that because we have only one valve and one speed sensor, so that's why we want to activate it in start. One channel one sensor. So in this, like, only one valve and for both rear wheels, and one speed sensor located near the rear axle. The rear wheels are monitored together, and they both have to start to lock up before the ABS kicks in. So these are the diagram for the three types: four channel, three channel, and one channel. Now here are some advantages for the ABS. First is we can maintain directional stability. So let's say we are turning our car, and at that time, if we want to apply a brake, so it might happen that our car can skid in normal braking, but in case of ABS, it is it is stable and it doesn't skid because we have a traction, because our wheel is continuously rotating. So we have a better directional stability and control our we can control our steering, but while in normal braking it can skid over and might go off the road. ABS is safe and effective, and it automatically changes the brake fluid pressure as we discussed in our working principle, that it can maintain optimal brake performance under each wheel. ABS absorbs the unwanted turbulence shock waves and modulates the pulses, thus permitting the wheel to continue turning under maximum brake pressure. It has several disadvantages. It is very costly, and car need to maintain maintenance is required. So, but uh, if ABS doesn't work, then like, let's say ECU fails, then in that case it can work as a normal braking system. So that is helpful. Next is the references. These we have used, and that's the end of presentation. Thank you.